All right, so today we're going to warm up with 3 implicit differentiation problems, just straightforward, going fairly quick. You can try to work them ahead of me, check the answers. Again, I'm just going to work them as they appear on the board. So I have this 3-term thing. I see 2 terms on the left, and I see the 4 on the right. When I look at this, the easiest thing to say is derivative of 4 is going to be 0. When I look here, I see a product rule, and I see a product rule. I always start with the x term. So f prime g plus g prime f. The derivative of x squared is 2x, and the y squared is still there. Plus, now I'm going to take the derivative of y. It's y squared. So the derivative of y squared is 2y x squared. And now I need a y prime. The dy dx. Going plus differentiation. Plus, now again, I see on the next one, my f term is x, my y term, or my f term is x, my g term is sine y. So again, I start with x. Derivative of x is 1 sine y. Plus, again, it's plus to both because that distributes. If it was a minus sign there, it would be negative. Now the derivative of sine x times derivative of sine y. Derivative of sine is cosine y, and then we need the y prime. Now it is algebra. We got to get y prime by itself. So I catch that these 2 terms have y prime, and the other 2 terms have got to go to the other side. If I write all this out, that equals opposite side, opposite sign. And get this. Now I just factor out the y prime. And I have y prime times that. Divide both sides by this sum. So I can get it clear. So y prime equals negative 2xy squared minus sine y all over 2y x squared plus x cos y. And we have just found the first derivative of the above curve. Okay? We found dy dx. All right. So again, we want to find dy dx. So I see 3 terms. The one is derivative of 0x. Derivative of x is 1. The left side is very easy. On the right side, I have sine and then the quantity xy squared. So I'm going to have to do a chain rule, and I guarantee the derivative of xy squared is going to have a product rule. So here we go. Derivative of 1 is 0, plus derivative of x is 1. Derivative of sine is cosine times. Now we have to do the derivative of xy squared. Well, I always start f, g, and I always do x first. So derivative of x is 1y squared, plus then the derivative of y squared is 2y. Then we still have the x, and we have our y prime. Now the nice part about this problem is there's only one y prime, but we have to get it all distributed. So I get 1 equals, and I distribute the cosine xy squared to both of these terms. So I get y squared cosine of xy squared, the argument, plus 2xy cosine xy squared y prime. 1y prime, send this packing, 1 minus y squared cos xy squared equals 2xy cos xy squared y prime. Simply divide by 2xy cos xy squared, and I am going to get the final answer of that. One more. So we have tangent of the quotient x over y equals x plus y. Again, 3 terms, but I see on the left that I'm going to have a chain rule and a quotient rule, or maybe a chain rule and product rule, depending on how you want to set this up. I'm going to set it up as a chain rule and a product rule. And I will take the derivative of the right side first. How about derivative of x is 1, derivative of y is 1, y prime. And derivative of tangent is secant squared, xy negative 1, times, now I got to do the product rule of xy negative 1. Again, f, g, I always take the derivative of x first. So I get 1, y negative 1. It would be plus, I'm going to write it then, it's going to be minus. So the derivative of y negative 1 is negative 1, y negative 2 times the x times the y prime. Again, I got to distribute the secant into both of these terms so I can start separating. So I get y negative 1 secant squared x y negative 1 plus, now I'll change that to a minus, because a plus minus xy negative 2 secant xy negative 1 y prime equals 1 plus y prime. I can get all the y primes on one side, everything else on another. I'm going to send the negative and switch these two around, opposite side, opposite signs. So I'd rather quickly get that minus 1 equals y prime plus. Now, this is where I see students typically make algebra mistakes. Gotta be careful, because when I factor the y prime out, I get a 1 here when I factor the y prime out. So I'm going to show that as a whole step here. Let's keep this side. It's y prime, and that would be 1 plus xy negative 2 secant xy negative 1. And again, the other side stays the same. At this point, I think one of the things I better do, and I'll wait a second. I will say that an answer in an AP test would almost surely not have negative exponents, so we're going to take care of that in a second. If you are working with negative exponents, this is a fine answer. But we're going to take some time here and just clean this up. So this would be the derivative, dy dx. And if I had x and y, I might plug it in my calculator and just get a value. I would not bother cleaning it up. But I'm going to pause the video and just clean this up real fast from step. All right, before I get too far in there, I noticed when I paused the video that I dropped an x squared along the way when I distributed. I just put the 2 back in those 4 spots because it was secant squared distributing. I then get to writing everything here, and I'm going to find a common denominator in the top of y. So I'm going to take the 1 and make it minus y, put that over there. I'm going to change this and do y squared over here. And I can multiply by this. And when I do that, I'm going to get y times. Now, this is most likely how it would appear as a multiple choice answer on the AP. But again, the big thing is practicing and seeing the derivatives, seeing these first 4 steps. And again, just you saw how easy it is to make mistakes when I accidentally drop the secant squared. So keep practicing. This is implicit differentiation.